Right, so we got two pulse motors here today. We got our 120 shotgun, we're going to call it that, 120 shotgun, because these little things right here remind me of shotguns, or rail guns, some kind of like real powerful, acute, puncturing, penetrating force. That's what it reminds me of, because it goes about 2,500 RPMs. It's pretty cool. Um, Hold on a second. Can you see? Yeah, you can see this. This is the circuit board for this pulse motor. Hello, hello. What's going on? All right, so we got the gyroscopic pulse motor over here. It's not plugged in right now. We got this little bad boy. Reminds me of it's a 120-degree rail gun. You know, it's really acute energy that gets shot straight. Anyway, I've never seen one work like this. You know, usually I'm making big fat coils with long trigger strands and, you know, potential energy and all this, but look at these. Anyway, we got MPN transistors. I think they're like CS2500s or something. Hooked up in parallel. Each coil here has its own transistor. $1,900. 2040. Holy smoke. 2100. 2150. 22. And then it turns off just that easily. You better just turn it down here. Let me show you. 2267. thing is awesome. All right, but I want to show you, I mean, I got a couple videos out, and I've gotten some reactions. I don't know, man. I think it's cool. Considering it's all weighed down with cores and everything, and it's axial flux, I think it's really cool. All right, so we're gonna hook up our commutator plates. Negative is the center. Positive is the outer square ring. All right, now let's see here. Oh, let me show you what's underneath the hood here. We got one transistor being triggered by a reed switch. These are all hooked up in series. Naturally, there's only one transistor, so they're hooked up in series. They're bifilar coils, but the trigger strand is not in use right now. So we're just firing on the 20 gauge strand. Should work with about 12 volts. And we're going to start off. Let me just juice it up gently. You can see it wants to move, but it's got some friction it's got to overcome. And some weight. Nine volts, 0.5 amps. That's where it started. Like really moving. Or kind of moving. It's now continuously moving in the opposite direction as the rotor. See, I had to make this armature to put the reed switch in the correct position for such a reaction to occur. There was no other place to put it. I tried everywhere. I tried below, tried above, in several different places, and this is it, man. This is the spot. So, yeah, it kind of looks like something from a sci-fi show, maybe. But that's okay. All right, 12 volts in. Look at how fast the rotor's going. Oh my God. Let's get a tach reading. Divide by 3. 2370. 2370. Gonna reset. It likes to be reset every once in a while. Hopefully I didn't blow the switch at 12 volts. That would be not good. I think I'm getting something's caught on something. Yeah. But I love how fast this rotor goes. And that'll spin for a good, however long afterwards. So if you got like a switch ready, some kind of switch, you can hook up the 32 gauge strands, and voila, you get quite a whip there to generate electricity with. After you turn it off, it'll go for a long period of time. I gotta see if we're good or not. So everything's still working. There's just some sort of hang up on the commutator, and I'll fix that. Maybe not. Here we go. Twelve volts in, 0.8 amps. Oh, it's axial flux. First one of its kind. No, I'm just kidding. Uh, it's the first one I've seen function that's a DC axial flux motor that's counter rotating. I haven't seen one. I encourage anybody to make one. I encourage you to build something. I honestly do. If anybody's listening, man, I encourage you all to get out there and just do it. Don't let anything get in your way, because that is what you're trying to overcome, is what's getting in your way. Look at that. See, that's what I'm talking about. Like, somebody says you can't do it, then you do it twice as hard. Okay? And you do it the same way they said you couldn't do it. You can't do it that way. You do it twice as hard the way they say you can't do it. Bam. There, enough said. Is there anything here that I shouldn't be doing or that I can't do? And I want to make it clear that I tried all sorts of trigger coil connections with this. Because the trigger coil will trigger in both directions, you do not get gyroscopic rotation. It doesn't happen. Because the force isn't there. It's biforcial. Goes both ways. It's got to be in the trigger. It's got to be in the way the direction the energy is flowing. It can't be a bidirectional thing. At least I haven't found a way to make it work. And I've done series, I've done parallel, I've done everything under the sun. And all the only thing that would happen is that the rotor would spin. Naturally, you trigger the coils, the rotor's going to spin. But the bottom part wouldn't spin. There's either not enough force, or the counter force isn't there. Because I think it's just because it's a trigger strand, and the trigger strand can work both ways. That's why I think it won't work, at least the way I'm doing it. With the power, or I don't know what it is. Man, but okay. So I tried to parallel like each coil gets its own trigger. The triggers aren't like long enough or tight enough. I'm not sure which one it is. These coils are actually pretty loose compared to what I normally roll because I rolled them by hand. So they generate about 0.3 volts on their own. So I wound them in series, and that was enough to trigger, it would trigger, but it was a series in all three of these coils. So I hooked the trigger strand in series together in these coils right here. And yeah, it was enough to trigger. I had 3 transistors in there, and I was running parallel circuit. And it would go up to about 3 volts. I'd love to see more of these. So if anybody's got a link to something cool, I'd love to see it. Honestly. So anyway, it was triggering, and it was all linked the right way and everything. And I could spin it this way and I could spin it this way, but the bottom wouldn't move, no matter what I did. And it's either because, and I think I know that what my explanation is legit. Because as soon as I put the reed switch in, and you had directional force, it started gyroing immediately, like instantaneous, did it on its own. All you had to do was turn it up and it worked. I say that's pretty well put together. Eight volts. We got it going at 8 volts this time. 0.4 amps. So amps aren't really a big deal here. It's like you need some amps, of course, you need some current. But I mean, volts are more important. The more volts you can get in, the more you're going to get out of this. I mean, you want amps too, but you don't want it to burn out your circuit before you get enough volts in. So but like I need this, I haven't secured the wire there for the reed switch because I'm probably going to blow it, and I'm going to need to put another one in there. It has to be, I can't glue it down, but I should probably readjust it because it looks like it's about to get caught on something. But that rotor is going exponentially quick. There's quite an air gap in there. And then the bottom was just spinning a little bit. Imagine if they were spinning and continued to spin like at, both the same speed. And then the speed would increase exponentially. Because I've seen it just with it spinning like it was. It increased the speed of it by so much. And it does the same thing when the trigger coils are firing. Instead of reed switch, when you're using trigger coils and you gyro it, the frequency increases. The frequency increases, so the sound and the frequency increases, but the speed of the rotor itself did not increase because there was no counterforce. I'm just saying that I found out some pretty interesting things working with this. Whether any of that data is legit, I don't know, but that's what my experiments have shown me. And if you can get a trigger coil to fire off one of these, man, show me, please. I want to see it, and I want to basically replicate it because that's pretty dope. 2 rules. It's got to be DC. That's rule number 1. Okay, no AC tricks or anything like that. We're not doing that. It's got to be DC. It's got to be fired off by a trigger coil. Both of those have got to be the answer. Anything else is good. It's kind of a challenge, you know, like I'm kind of like encouraging people to, at least whoever's into it. Well, why don't you just listen, Tyke? Stop trying to figure out stuff on your own, and I'll just fill you in. But yeah, I understand. It does look like a Roomba. That's what I was going to say. That's what everybody thinks. It's a Roomba. Whatever you say, dude. And I ain't trying to do shit. It's done. I love this thing, man. Need to get a little stand here for the switch. Hell yeah. Haha. Woo! Do not get skinned by this thing. Something happened. We'll figure out what just happened. Looks like, I think one of my bearings just blew a gasket. That's what it appeared to be. Let's see. Oh, damn it. Oh, there we go. Oh, that's not right either. Oh. Actually, I think I need this. Because Thermal viscosity breakdown is what I think is going on there. All right. In other words, the shaft got sticky. So that definitely sounds like it might be the bearing. Looks like it might even be the mag-lev underneath. Let's check that out. What do you know, man? That thing came detached. Oh, don't even really need it on there. I'm glad it's off. I'm glad it's off of there, actually. Because I'm like using that flange right there. All right, back in business. $27.53. That's awesome. And then what these coils are made out of is an iron cord. It's a 1/2 inch thick. And then it's about 4 inches long. It's wrapped in 2 layers of 20 gauge. And that's it. No triggers, no nothing. Just straight 20 gauge, 2 layers. I don't know, man. It's 4 inches. It's a 1/2 inch diameter, and it's 2 layers, man. There's your data. Oh man, I love it. I love it so much. And I was just getting on here early to show you. I mean, this is the axial flux gyroscope. I've made 2 other gyroscopes. They're all DC so far. I haven't done any AC. I don't have AC power just yet. I mean, I have it coming out of the wall, but I don't have anything to harness it other than a plug. And I'm not crazy enough right now to retrofit other than my power supplies. I feel safe with it having that little glass covering it up. It's pretty professional. I don't know, man. I'd have to use a lot of tape if I was going to mess around. You know, I have to cover up everything real good. But the circuit for this is just one transistor. Everything's in series. 20 gauge. Each one of these coils is about 250 turns. They're wedge shaped and they're iron infused PLA. So they have a core. There's magnetic flux going on. Not much more you can ask for. And if it really is about all these, you know, lines that I can't see with my eyes, then why does it matter if it looks like a Roomba? Why does it matter? Or does it not matter? And it was just an observation. I don't know. We'll see. So we're going to go back and forth actually. But each time I do that, I got to disconnect the power. And then connect it back up. So negative, positive. It's the simplest thing I could think of on how to hook up the transistor with the power. Let's have brushes hang down. Spun it the wrong way, you can see. But the air gap is so large that it would have kept going without correcting itself. And I think if I make the air gap just a little bit less, I don't think I can though, because the transistor is why it's so big. Everything is the way it's supposed to be because of something else in the build. So it's like, no. The answer is no. And I wanted the trigger coil thing to work so bad that I stayed up for like a day and a half just trying every different combination of what I could do, and negative. Because you can spin it both ways, it won't gyro. There's nothing pushing there. It goes both ways. So I mean, there's obviously a way that it'll go. I'm gonna reset it. Here, let me see if I can let's see if there's any more brushes that shouldn't be touching. This one should not be touching. And it's set up, I got 3 brushes down there because there was 3 transistors in here. Hell yeah, man. And that's a badass Roomba right there. I'm trying to see what's obstructing it. And it's just because it's a rocky road. It's like not flat, the commutator plate, which would be really nice, but it was rolled up when I unrolled it. I flattened it out the best I could. I don't have all these tools that I should have to do all this stuff, but I want to do it anyway. So, there. Oh. Look at that, man. That is still spinning like really, really fast, and those magnets are really, really powerful. So I'm thinking that those 32 gauge strands that are just floating there could actually be generating or doing something. And what I think they can be doing, short of shorting the coil out with a few diodes, could be feeding the coils. I mean, if that magnetically induced electricity has any power whatsoever, then I should be able to hook up a diode and maybe ground it. Maybe it has to be grounded, but there should be some sort of power surge going from the 32 to the 20, as long as the coil 32 is grounded and has a diode on it. And it's really easy to do. Really easy to do. It's really easy to ground it because we have a breadboard right there in the rotor. So you plug it into the ground, the trigger coil, or whatever you want it to be at the time, you plug it into the ground. Then it's connected to the ground. You take a diode and you plug it into the front of the coil, and that where the power's going in. You plug it into the same hole, or if you can, you get one of these 3 or 2-way splitter into one, and you plug it into that hole, and the one comes out the other side, and you're all good. I don't know. I've had a really bad couple days here, just personally. So, I'm not finding things very funny right now. Things just are not clicking. I spent way too much time. Not like it took a long time to do, but I did it all consecutively, so I'm kind of worn out. And then it ended up looking like a Roomba. So, go figure. But hey, man, I can't judge. I can't judge. That's for other people to do. I mean, what I mean is I can't judge you for calling it a Roomba. I think it looks like a Roomba too. But it's got to reach a certain voltage. Right now it's at 6, but it needs more force than that. Nine volts. That looks good. I want to see what it's getting caught up on. Looks like it's just a bump. Just a bump. And see how that's all it takes for the lower part to slow down is just an obstruction. So I don't know, I'm gonna try to somehow flatten that out even more. But I had to cut a hole out of the center of that and have it be one solid piece on the ring. So that's never pretty. I mean, you can try, but that's never gonna be pretty if you're doing it by hand, which I am. Then don't do it by hand. Oh, well, yeah, you buy me whatever I need, milling machine or whatever, and I'll use it. I'll make you some stuff that you want to see really bad. I will make that for you. Just buy me the tools I need. Right? Until then, I can only make you what I can make you. Make me what I can make me. You know, I do this for me, but I show you guys because it's something to do. And God, if you really enjoy this stuff, it's really cool to be able to see it. I mean, seriously, if you find one of these on YouTube or any other station, send me the link. Because I want to see it. I want to expand my knowledge on it. And I want and gyroscopic. It's got to be counter rotating. Can't be anything else. It's got to be DC with or without a trigger coil, though. Trigger coil, I would like to see it with a trigger coil. Sorry, though, for not interacting with the crowd here. I'm just typically enthralled with what I'm doing. Sharing it with you. It's not that I don't want to be interacting with the community. I really do. Yeah, it's an axial high flux. You should definitely know an axial flux when you see one. Tell me it's not. Tell me that these coils are not lined up with the axle. Tell me that these magnets are not lined up with the axle. Go ahead. It's an axial flux pulse motor. I'm just assuming that there's going to be a lot of debate as to what this is. Saying there's no need for any of that, man. I'll tell you straight up. It's an axial flux counter rotating pulse motor. But we're moving on to Shiny Little Devil right now. This is a 6 magnet rotor, and these are 3 basically iron chunks with, I want to say, maybe 50 turns of 20 gauge wrapped around them. Ooh, yeah, that's going fast. Nine volts, 2.2 amps, 2500. So neat, man. And I just bridged that gap like a couple days ago. I was stuck at like 1600 RPMs because of the way I was building my coils. The coil design left a lot to be desired. I mean, just look at that. That's a teeny ass coil. And that's making, it's a teeny rotor too. So that says a lot for the teeny. And we just had in between 2,500 and 2,700 RPMs. And it's so rudimentary that it's like literally if it was okay with me, I'd let my son do it. But he could get really hurt just by touching the wrong thing, so I don't let him do it. Takes a little bit of common sense. You know what I mean? Robert, thumbs up, man. Good to see you. So, for those members of the community that really want to engage and talk about this stuff, I'm sorry I'm ignoring you. Wow. Come on. All right, we got it up pretty dang close. Pretty dang close. Let me show you. 29, 39. Wow. Man, you got to understand that being trapped at around 1,500 RPMs for like 2 years, breaking that and breaking it so soundly is freaking cool. It's like achievement. Yeah, I don't know, man. I really, it's okay. It's okay, man. I'm allowed to feel the way that I want to feel about stuff, regardless of what the rules are. Whew. I don't know. I think it's all really cool, but I think there should be a little bit less talk and a little bit more do. Check that. There should be a lot more do and a little bit less talk. Because you got to talk it out, but you got to start doing stuff, man. I mean, seriously. And if you're doing stuff, show people what you're doing. I hope to lead by example. At least at that example, I am a first mover. At least I consider myself to be a first mover. So people can look at what I've done if they want to do it and then do it better the next time. That's what being a first mover is all about. You're never going to have the best iteration of what it's going to be. It's never going to happen. Because somebody's always going to stand on your shoulders and do it better. Always. Because there's always going to be a way to do that. or there is no free energy. You get what I'm saying? Can't have one without the other. And all this right here, definitely not free. It might be cheap, but it's not free. And these two things don't even generate electricity at all. I mean, there's probably some place you could probe to get some readings, but if you do that with this, it's not going to work right. And this, the magnets are just so small, you're probably going to get maybe 60 volts off of induction coil, like so. You know, you just put it right next to it, and that'll be enough to light a light bulb. You can definitely light a light bulb, whether you're spinning it with a motor or spinning it with your finger. You can light a light bulb. Hey, good afternoon. As much as I can tell, we got pulse motor mayhem going on here. They are currently both just motors. As I just got done explaining, if you try to probe the gyroscope in any kind of way, shape, or form that isn't aerial probing, you're going to tether it. So you can't clip any wires to this. So you can't like generate electricity that you can read with it. But if you know what's going on and you know electricity is being generated, I have an idea, a circuit or a connection repertoire that you could do. And that's take the trigger coils from here, because I tried doing this with trigger coils, and seriously, somebody's got to show me it working with trigger coils, because I am now convinced that because you can spin the rotor either way using trigger coils, that it won't work. You need either a Hall effect sensor or a reed switch of some kind, or some mechanism that generates the same counteractive force. If it spins both ways, you don't have that force. Or if you do, it's worthless, really. So I got my brushes. This outer plate right here is the positive. And then there's an inner plate resting on the maglev, which is for the negative. It's a real simple, goes through a transistor, but it's still really, really simple. But anyway, you take the 32 gauge strands and you ground them, and you hook a diode to the other end, and you stick that end in the power for the 20 gauge strand. If you get what I'm going with this. As long as they're grounded, that electricity should go through the 20 gauge strand, which allows the motion to continue at least a little bit. If I was trying to make it go forever, I'd be crazy. It'd be crazy. It just would never happen. And you would try everything 3 or 4 times and it wouldn't happen. And I was saying like everything. But I'm just curious, as if you ground those strands, that's the key, because it's DC. If you ground them and put the diode on, will it help the motion of the motor? Because that's about all you can do. You can't read the electricity coming off of them, because then you tether it. And that is not what this thing is all about, being held down. I ain't got no crystal ball. So all I'm going to be doing today is going back and forth with hooking up these connections and turning these on and off. If you have any questions, feel free to ask. If I see them, I'll answer. If any of my moderators decide to come, and it's totally up to them whether they come or not, they can help you. They're all really knowledgeable people. Uh, some are younger than others, some are older, but they all have knowledge. You can see it wanting to work at 4 volts, 4.7. Rotor's starting to move fast, and it's faster, not fast. That's really slow, but that's not the point. You can see it wants to move, but there's some friction, maybe some weight. Six volts. 7. 8.5. 10. 12 volts, 0.6 amps. And that amp draw will continue to go down as long as it continues to function the way it's functioning. See, I don't know, in this day and age, and to me, it's kind of hard. It's always been hard for me to tell if somebody's got my back. It's a curse, man. I just don't know. And I always just chalk it up as nobody's got my back. And that's the way I look at life. If you can't do it on your own, the chances that you're going to get it done decrease by half automatically. But then there's that 50% chance that you're going to meet somebody that you can work with. I don't know, man. I got lots of I wouldn't call them mental problems. It's not anything that other people don't have to deal with. So I'm not trying to look for sympathy or anything. But yeah, I deal with depression and stuff like that. So when I take the time to say that I've built you an axial flux, gyroscopic, counter-rotating pulse motor, don't call it a Roomba. Love you guys. I know it looks like a Roomba, but I just took the time to say a tongue-twisting vernacular, and it took is equally as intricate to build it as it is to say it. You know. To come up with everything that you need, the pieces, whatnot. All right, that cord is dragging. So yeah, man, I take it personally. Yeah, you're not funny. You are not funny. I don't care if you have a million people laughing at you. You are not funny. And I'm definitely not funny. Well, I don't know if I'm funny or not, but I definitely don't have a sense of humor. So if that means I'm not funny, I don't know. Maybe it does. All right. But I like to say what's on my mind. I like to do it in front of a bunch of people. Does that make me demon-esque? Maybe. But it's only an esque. It's only like a motif. It's nothing else. I like to, and I'm wrong. Like 65% of the time, whenever I go after somebody, it's usually miscommunication. And so that I value communication. But if you don't want to communicate, I don't see that as being my problem. And I will continue whether we get a chance to talk or not. No, I value you, but I don't want you to get to the point where, there's a very famous saying, they get to the point where they don't think they need you, and then they just move on. You know, I hate that situation, man. I avoid it at all costs. A lot of people don't even experience that, but I've lived on a darker side of things, and I experience it ever so often. And when I say a darker side of things, I have a bad mood, like a lot of the time. That's dark, okay? It gets in the way sometimes. I'll guarantee it, man. Having a bad mood and expressing it gets in the way of productivity. Those are wise words right there, man. If you have a bad attitude, keep it to yourself. At least try to. Or if you're going to express it in a way where you're trying to teach somebody not to do it, because it's really just it's terrible. And when I catch myself doing it, having a bad attitude, I try and check myself. Because it's no fun, man. It's no fun for me. It might be fun for you, but it's only going to be fun for you for a little bit. I guarantee. But I don't know, man. People got a healthy balance of doing that BS and then they can rebound from doing that BS because they got charisma and all that other stuff working for them. But they're still jackholes, straight up, man. So it lasts for a few more years. I mean, it's just if you don't learn from your mistakes, you're bound to make those same mistakes over and over and over again. Like in my motors, They're not mistakes, they're just ways that I learned how to build because I taught myself how to build. Basically, I mean, I got some basic connection theory from a few people that thought I was doing was interesting and they wanted to help me out. And thank you very much for helping me out. Peter Hall Effect, 007. I'm giving shouts out right now over Unity Research Channel. Um, all these people that helped me out, thank you very much. I sincerely appreciate the knowledge that I've gained from working with you. You made all this possible. We're going to get over 3,000 RPMs this time on the little guy. So this is pulse motor mayhem. What we're looking at here is an axial flux, counter rotating DC pulse motor right here. We got the reed switch on an armature because it had to be in position as such. I tried everything as such. All right. And I don't mind. I mean, seriously, like if I was going to build it again, I'd make it all one piece so that there's no chance that that arm would fly off. But just the bottom spinning that fast has increased the top rotor speed by double. Or at least half. And like I say, right now, since I've turned it off, if we put those 32 gauge strands, ground the one end, and then put the diode into the positive end of the 20 gauge coil, could it make it move a little bit more? I think so. I think that electricity is good enough to, as long as everything's grounded, I think it'll work. But it's not an AC, so you have to ground it. You don't want to mix the two because it doesn't work very well. All right. All right, so I'll say again, I'm talking about the 32 gauge strand. We lift this up underneath here. We've got wedge-shaped coils that are bifilar, wrapped about 250 turns a piece. We've got a 32 gauge strand in there that's virtually not doing anything right now. So if we wrapped it up, each one, or put it in a series and grounded it, because the other one's in series too. The 20 gauges are in series right now. So if we wrapped them in series and then grounded the one end and put a rectifier diode on the other end and shoved it in this hole right here. Yeah, baby. Then that 32 gauge strand could be doing something, maybe. But you'll never know. You'll never tell. There's no way to read it. The only way you can read it is by visually seeing whether it's spinning longer or not. And that's what I love about it, man. You gotta use your senses. And you could be totally wrong. That's the joy about it. You can be really freaking wrong. I'm wrong all the time. I admit to being wrong all the time. But I also admit that I put the time in. And Yeah, man, I don't have to be right all the time, or any of the time, actually. Proof is in the pudding, man. It works. And yeah, I got a DC motor under the table. You want me to show it to you? It's way over here. Right there. Jackass. Everybody's got to be a smart aleck, you know what I mean? Yeah, I'm talking to you. No, it's for my personal satisfaction, and since you're taking away from that, I don't know. Could politely ask you to leave, since I don't have any moderation at the moment. Has anybody ever seen a pulse motor where the coils are spinning one way and the rotor with the magnets is spinning the other way? Has anybody ever seen that? Wow, you've seen it. You've seen it now. Find me a better one. Make me a better one. I thought trolls were afraid of the sunlight, man. .3 amps, dude. That is so good. I mean, you're not the only one who can be a jackass. It's like so unoriginal too. I mean, I keep on getting the same same comments. Don't worry, man. I can react, I guess. Yeah, I gotta forewarn everybody. I'm pretty bitter, so I'm just saying. Let's see what we could do. What I'm gonna do, actually. See, that rotor is still spinning and still spinning pretty fast. So that idea with the 32 gauge coils might actually be a thing. Not perpetuum momentum, but increased mobility. Kind of like having an alternator, maybe. And a hybrid vehicle. Okay, so what I want to do is I want to get this hooked up without wrecking anything. my daughter's home. Hey, Paige. I'm gonna have to get over there. Short of putting a rectifier on this, we're gonna do some AC voltage generation on the little devil. $20 volts. $50. Hi, Paige. 2,600 RPM. 55 volts. All right. Hi, you want to come in? All right, so you're home, so that means, uh-oh. That means I gotta go pretty soon. Pick up my son at 3:50. Yeah, man, just because I look like a backdoor bum doesn't mean that I'm not professional. Just because it's rudimentary doesn't mean that the concepts aren't sound. So that's awesome. This fat coil here will generate 55 AC volts at 2,600 RPMs. Now, if you had 6 of these big ass magnets going 2,600 RPMs on that dude, you'd be generating over 1,000 volts. All right, whatever the potential energy of that coil is, will automatically be generating that much if you use magnets of this magnitude. And the reason you can do that is because this coil is not hooked up to the power supply in any way, shape, or form. So if I just do this, 16 volts. If I plug a light into that, it's gonna light up. And look at this dinky little thing, man. Maybe not a 100-watt light bulb, but one of these LEDs, one of these 12-volt ones, light up really bright. This is a 15-watt bulb. I bet we could get this one to light up. Might have to turn it on though. But I know that and that's with this is a single file, 32 gauge, 1800 turns, iron core, soft iron core. Me personally, I'd like to turn it on because I mean, I started out, when I first started out doing this. And I wanted, for the very life of me, to get away from that. I didn't want to have to spin it myself forever. Now, if you find a different mechanism to spin it, I'm sure it's not going to be free. If you find a free mechanism to spin it, wow, woo-wee, man, that's going to be worth some money. I'll tell you what, because if you can spin this thing for free, even me doing it with my finger, if you want to consider that free, which it isn't. But I'm more interested in this little thing that I have going on here. If I can ground those strands, hook them up with the rectifier into the power stream, dude, you saw how like much this spins after the fact. After I turn it off, it continues to spin for quite a while. So if there's something generating electricity and sending it in a specific direction, even though it's not motor ready, the stuff coming out of those coils will not run a pulse motor. It'll turn on a light, but it won't run a pulse motor. But I think it might like not perpetuate, but like extend the motion range of the disc after the fact. In order to test that, I'd have to get some pretty accurate readings. But I think, just based on the way that everything is wrapped, that would work for a little bit. If it has any effect at all, it's working, okay? Because I'm not putting a stipulation on it that it has to move forever. So if it moves at all, it's working. I win. I win. That's cool. I like winning. I don't believe in perpetual motion. I just don't believe it's a thing. I believe that things can move forever as long as there's a power source of some kind, some balance. Because when there's an imbalance, you get a spiral, a downward or an upward spiral. A distortion, in what is, in other words, a pretty wave. So you know what? To go with your stereo amplifier, I'm going to get you a distortion pedal for your birthday. How's that sound? That would just be so cool, man. You hit that distortion pedal and that thing is going to change frequency, even though it's pounding on the same note. So cool, man. And why haven't other people thought of that or done that? Especially if they're hooked up to a stereo amplifier, man. Get that distortion pedal. Change everything up, man. Distortion is beautiful. I mean, symmetry is beautiful too, but you know, it's all beautiful, man. If you can't appreciate one end, how can you appreciate the other? Truly. And I appreciate people that have a lot on their mind and like to talk. Get out what's on their mind, like I'm doing right now. But you got to share the floor. You got to share the floor, man. Yes, this is a representation. No, not even a representation. but it was inspired by Otis T. Carr's XT1. All of these were kind of inspired by that, having the gyroscopic thing. And it does increase in speed, but not with the trigger coil. It only increases in frequency, which is weird. It doesn't increase in speed, it only increases in frequency, which I find to be, I thought that would be impossible, but my ears do not deceive me. I think it's the ability of the trigger coil to allow it to trigger both ways, which makes that possible. The increase in frequency without the increase in speed. Because when the bottom one starts going, you have to push it, but when you push it the right way, the opposite way, you hear it speed up, but you don't see it speed up. Because it's not even really going fast to begin with, so you can tell that it's not speeding up. But when you push it, the frequency will increase based on the sound that you hear. That's legit. That's science. That's observation. Good science is good observation. And I don't have to write it down because nobody really cares. You know what I mean? At least that's how I feel about it right now. So how is it supposed to look? Let me ask that question. How is it supposed to look? Well, I might come back later on tonight and we'll do another one. Hopefully I'm in a better mood. We'll see. But I might be able to show you what I'm talking about with the trigger. How it's not gonna gyro with the trigger strand. Maybe it's just not enough force, power. Like, I don't even know what the problem is, but I think it's because it spins both ways, or it's capable of spinning both ways. With the reed switch, it's one way or the other. And yes, it applies to both discs. That force applies to both discs, the one with the coils and the one with the magnets. When I talk about counter force, I'll show you the difference between the reed switch and the trigger coils and why the trigger coils aren't going to work. Now, a Hall effect sensor might work better than a reed switch in this instance, but you're going to need one or the other. At least that's where I'm at right now. And I might try the trigger coils again, but I'm pretty sure I tried every combination under the sun with the coils that I have. Maybe make different coils. We'll have to see. Right now, these are working pretty good. I mean, you can, when it's on, dude. And hold on, let me check the time. Got about 3 minutes and then I gotta go. I'll probably leave the stream running actually, because I'm just going down the street, but I won't be back until, it's gonna be a literal break. I won't be back until like 5. No, I'll probably stop it just to be prudent. See, man, I talk too much. Forgot to plug it in. So I'm going to leave you guys with counter-rotating axial flux pulse motor. Here we go. juice it up a little bit. That is too cool, man. Uh-oh, we're losing something. It's not that funny. Gotta tether that line down. Look at how fast that is going. That's some torque, I would assume. All right, I'm about ready to take off.
I just got here.
I'll see you guys later.
What?
Peace out. Have a good day. Say hi, Paige.
Hi. Or bye, I guess.
Thank you, Herman. Somebody ought to wash your mouth out with soap.
Indeed.
Old Man Builds, thanks for stopping by. I really appreciate it. Bebop, you the man. Peter Hall Effect, thank you so much for coming in. Yeah, dude, I don't even know. Sorry, you're kind of just there. I don't even know what to say. Peace out, everybody. I'll be back later.